Hi, Susan. Can you hear? Okay, great. Welcome back. Okay, good morning. Okay, let's go ahead and get started. Looks like there's another student in the chat. It's actually, I have a second computer running at home because I just wanted to see how things look. So it's really just you this morning. Okay, I'm going to go over just one section today, and then at the end, because this won't take very long, I thought I'd go over it to our online class just to kind of go over it for students in case they're having trouble finding things. So we'll do that at the end of the new material. So this week, okay, this is MGF 1107, and it's what we call a survey course in mathematics. And we go over a series of different topics. And the first topic that we're going to go over is numeration systems. And this week you only have one section to cover, which is section 4.1. And let's go ahead and take a look at some of the material. Okay, so the systems of numeration, a couple definitions. In this class, there's going to be a lot of definitions, kind of like you saw in your MGF 1100 class. So a number is a quantity. It answers the question, how many? And we use numerals, which are symbols, to represent numbers. So in different numeration systems, let me get my little pointer here. This is a symbol or a numeral. This is in another numeration system. This is in our numeration system. But symbols are numerals that we use to represent the numbers. And that's what we're going to learn about in this section, 4 different types of numeration. So the numeration system is a set of numerals and a scheme for how we represent the numbers using the numerals. And we're going to study 4 kinds of systems, and they're used by different cultures. We have an additive, and I'm going to go over examples so you understand what they mean, a multiplicative, a ciphered, and then a place value. And we'll go over an example of each type. So additive systems is one where the number is represented by a set of numerals, and we add up the values of the numerals. And this is one of the oldest and most primitive types of systems. And we'll see in a minute why it's not really a great system in certain situations. Some examples are the Egyptian hieroglyphics. I'm going to go over an example of that. And also Roman numerals, which most students are familiar with. And so here's the hieroglyphic symbols, and you want to keep these close by. I think when you're working the problems in MyMathLab, I think they actually have this little table in each problem. But if you notice here, this is our system. Our system's called the Hindu-Arabic numeration system. And then here's the numerals that the Egyptians use, and then here's a word that they use to describe it. So this is looks like a number 1 actually. They call that a staff, a heel bone, lotus flower, astonished person. But these are the hieroglyphic symbols, and then these are the equivalent in our numeration system. So let's take a look at a problem. And I wish I had kept that little table over here, but we'll flip back in a minute. So it says, write the following numeral as a Hindu-Arabic number. So take it from the hieroglyphics to our system. And we notice that there's groupings here. So there's 3 of this symbol. And if we go back and take a look at that little table, that symbol was the pointing finger, which is worth 10,000. So right away we have 3 of these, and then we have 3 of these, which were called the, is that a loop? Scroll, which is 100. And then we also have 1 of these and 3 of the staffs. So what we're going to do is we're going to say, okay, each of these pointing fingers is worth 10,000. Each of these, what was that called? A coil, did I say? Yeah, scroll rather, is worth 100. So I write 3 of those down. And then that heel was worth 10, and then there's 4 staffs, which are just worth 1 each. And then what you do is add this all up. That's why it's called an additive system. Okay, so when you add it all up, you get 30,134. Now, imagine though, if you're going to do a really big number, you're going to have lots of symbols here. So this is not a great system for representing big numbers. Let's go the other way. Let's take a big number and write it as an Egyptian numeral. So again, you want to break it down. And this is what we call the expansion of the number. We're going to learn more about this in a second. So this is 1 million plus 200,000 plus 3,000 plus 400 plus 60 plus 2. And then this helps us to write it into the Egyptian symbols. And the symbol for 1,000 was the astonished person. And then the 100,000 was a tadpole or a whale, and we've got 2 of those. And we have 3 lotus flowers, right here, 3 lotus flowers, 4 scrolls, and then the heels. Question? Well, yes, exactly. And also, I don't know if you started working on your homework, but you'll notice you don't have to write this out. Obviously, these are going to be multiple choice questions. Going the other way, if we take it from here to our system, you could type in an answer. But on these, they're going to be multiple choice. Yeah, these get really, really big, really, really quick, which is one of the reasons why the numeration system didn't last. Well, it lasted a long time, but it's certainly not used nowadays. But again, what you're going to do is what we call an expansion into the different numbers that make up the overall number. And then you just put the symbols in. So pretty straightforward. So that was Egyptian hieroglyphics. Roman numerals, most students remember Roman numerals. And here's the Roman numerals, and here's the quantities here. Now this system had an advantage, 2 advantages actually. One is it also uses a subtraction principle as well as an addition principle. So for instance, if you want to write the word or the number 600, so D is 500 and C is 100, so 500 plus 100 is 600. If you want to write the number 400, we use a subtraction principle. And so if a symbol for a larger number comes after a symbol for a smaller number, then we know we're subtracting. So for instance here, this D is 500 and then the 100 comes after it, so we're going to add. Here the 100 comes before the 500, so that tells us we're subtracting. So that's a real advantage. Cuts down, instead of having to write out 4 C's, we actually only use 2 symbols to represent 400. The other one is it uses a multiplication principle if we're going above 1,000. And what it does is it puts a bar over top of it. So instead of writing out 5 1,000s, we can actually just put a line over the symbol for 5, and that tells us that it's 5 times 1,000. And so again, this saves us a lot of space when we're writing numbers. So this is kind of the next step in terms of making the system more efficient. So it has a subtraction principle and a multiplication principle in Roman numerals. Here's another example. So if we wanted to have 400,000, all right, we already said up here this was 400, so if I put a line over top of it, I multiply by 1,000 and that becomes 400,000. So now I've only got 2 symbols to represent a pretty big number. Again, in hieroglyphics, what would you have had here? You would have had 4 tadpoles. So we're making the system a little bit more efficient. So let's take an example. So let's go from Roman numeral back to our system, the Hindu Arabic system. So the first thing you want to do is an additive system again. So I'm going to break it into parts. And so I notice that the 100 comes before the M symbol, which stands for 1,000. So I know that this is going to be a subtraction principle here. And then I have an L, and L is 50, and an X. And again, I notice that the symbol for 1 comes before the symbol for 5, so I know I'm doing subtraction again. So I want to go ahead and write it out like this, break it into its parts. And then I know that this is 1,000 minus 100, plus 50, plus 10, and then this is 5 minus 1, which is going to be 4. And then again, we just add these together. And so this number is 964. Okay, and then I think I've got one going the other way. Let's go back the other way. So now let's go from our system to Roman numerals. So the first thing you want to do is write it in that expanded form. So this is 400 plus 30 plus 9. All right, so we already did 400, remember? Oh, I'm going to write it, I'm going to use it as a subtraction. We're also going to use 9 as 10 minus 1. And so we did 400 before, remember that was LD. And then we have 3 tens, and then we have 9, which is the 1 in front of the 10. So there's that 439 written in Roman numerals. Okay, so those are the additive systems. Those are the only ones that we're going to study. We're going to go over the Egyptian hieroglyphics and then Roman numerals. All right, and then let's go take a look at multiplicative systems. Now these are similar to the system that we use today, the Hindu-Arabic system. And one example are, oops, came up a little funny, but Chinese. Now these are really interesting because we have no really way to describe these other than just look at the symbols. So there's symbols for 1 through 10, and then 100, and then 1,000. And so the process with Chinese, which is real different, is they're written vertically. Okay, and so for instance here, this number 20, and what happens is we multiply by the power of 10 below it. So this has got a 2 over 10. And then so we're going to multiply 2 times 10, which gives us 20. Okay, we take a look at this one and we notice that it's got a 4 over top of a symbol for 100. So this is 400. Okay, so that's why it's called multiplicative. And it's always going to you're always going to start from the top to the bottom. So let's work a problem. So write 538 as a Chinese numeral. All right, so break it down. 500, 30, and 8, just like you did before, except now we're doing it vertically. So this is going to be 5 times 100, 5 times 100. 30 is going to be 3 times 10, 3 times 10. And then 8 just sits here. There's nothing underneath of it because it's just 8 times 1. And we don't put the 1 there, it's implied. So you want to make sure you always start at the top and work downward by groups of 2. Okay, and then I think that's the only example I have on the Chinese. So that's a multiplicative system. Now a ciphered system, this has numerals for numbers up to and including the base and then multiples of the base. And the number is represented by a specific set of numerals that's again a sum. And this has lots of symbols. You're going to see in a minute. We're going to look at a Greek system. The problem is because there's so many numerals, so many symbols to represent it, it's a big system and you have a lot of stuff to memorize. But the advantage, let me just go back for a second, is the numbers can be written in a compact form. So again, we're getting more compact here. The systems are getting more complicated. So we're going to talk about the Ionic Greek system, and it was developed about 3000 BC. And it used the letters of the Greek alphabet as the numerals. And the base is a 10. And we use this little symbol iota, which is a Greek letter. It's going to be up to the left and above a numeral to multiply by 1,000, kind of like the Roman numeral system. But instead of putting the bar over top of it, we're going to use this little Greek letter, basically iota. Now, here's some examples of ciphered systems different cultures use. Hebrew, Coptic, Hindu, lots and lots and lots of places that ciphered systems were used. And each of them would use their own symbols, obviously, but we're going to just talk about this one, the Ionic Greek. Now, if you notice, there's lots of symbols here. So it goes 1 to 10, and then, now remember, above this we have the multiples of the base 10. So we have 20, 30, 40, 50, 60 up to 100, and then we have 200, 300, and then we have to go up to 900, and then beyond that we use that iota for multiplying by 1,000. And it also note here, some of these are Greek letters that are not even used in the modern Greek system. So it was developed so long ago that their letters have actually changed. All right, so let's write this in our system. So here's the symbols. So this is pretty easy to translate because all you need to do is go look up what each of these stands for. So this one is called, if I can get the name of it, this is a tau, and this is a pi, you remember pi from geometry, and then we have an epsilon. And if you look up the values of those, then all you do is add it together. And I'm sorry that overwrote there, but it's 300 plus 80 plus 85, 385. Okay, and let's go the other way. Let's go from our system back to the Greek system. So 1654. So again, you want to write this out expanded. So it's 1,000 plus 600 plus 50 plus 4. All right, so 1 times 1,000 plus 60 plus 50 plus 4. So we don't have a symbol for 1,000, so what do? I'm going to take the symbol for 1, which is alpha, and put that little iota up here, and that says 1,000 times 1, which gives me the 1,000. This is chi, which is the symbol for 600. And then we have, I'm looking up the names here, nu is the system for 50, and then for 4 is a delta. And so there's that number, now 1654, written in the Ionic Greek. And again, you put them next to each other like that. Okay, so that's all we're doing this week. You only have one section to cover. Any questions, Susan? Have you tried the problems yet? They're pretty straightforward, I think. Okay, but you'll have an idea of what we're going to look at. Now, next week we'll continue into further sections. We'll go into other bases, and then I don't have my book in front of me. I don't remember the titles of section 4.2, but we'll do 4.2 and 4.3 next week, which is additional systems, and then I'll change of bases. All right, so I was going to, if this will work here, share my screen, of course, in case people are having trouble seeing that. So let me go ahead and hopefully this will show up. Okay, there we go. So this is your My Courses course. You don't see the faculty tools, that's just for faculty. What I just wanted to show everybody was, number one, to register in MyMathLab, you use this link on the course. I'm on the course homepage now. All the way down to the bottom, you're going to click here, and my demo student is already registered. The first time you go here, you'll actually have to go ahead and register, put in your MyMathLab access code. And let me just go and show you where that information is. So if you go over to course content and go to MyMathLab, begin here, MyMathLab materials. And you've got a little video here. I'm not going to play it, but there's a little video here that actually shows you how to get registered in MyMathLab. So that might be helpful if you're having trouble. Let's go over to the MyMathLab course. I'm going to pick the whole course here, just so we can see. And the course here is set up, the ebook is set up the same way your modules are in My Courses. All right, and then your, get back here, your assignments are here. And on the assignment tab, I also put the textbook and video for each of the sections. So I thought that would be helpful, so you don't have to go searching through the ebook if you want to go look things up. Let me get back to the course for a minute. And then, just real quickly, this week we're doing Unit 1, all right, which is the historical aspects of mathematics. Again, if you don't see the discussion for this one, you haven't done the syllabus quiz with 100%. The little introduction here gives you a little checklist to go over for the module that might be helpful. There's the notes for each of the sections that we cover. And then your MyMathLab assignments. All right, and I think that's really all I wanted to show. Back. Yeah, we're back now. Okay. So I just wanted to do that briefly in case students were having any trouble. Okay, Susan, so next week we'll have more material, but this first week, just to get you going, we only do that one section, so that'll get your feet on the ground and organized in the course. So any questions, Susan, so far? You're good. Okay. All right, well, I'm going to end it early this week because, like I said, it's just the one section to go over, and next week we'll do 4.2 and 4.3. So you have a great week too, all right? And we'll chat again next week. Take care.